Hello, my name is Leon Turner from Trend Controls. I'm here to talk to you about our latest exciting release into the Trend portfolio, namely Iqenergy. Iqenergy is an energy monitoring and targeting package, which is designed so it can be built into our existing platforms such as IQ Vision, TON, and IQX. It will be released shortly, and as I talk in 2021, this will not be too far in the future. So by the time you listen to this, it may actually have been released already. We've released this to answer several questions that have been asked of us in the last couple of years. Firstly, what happened to the Trend Energy Manager, our outgoing solution, which was obsoleted off a year or so ago, and we have not managed to fill that gap until today. Also, how can I comply with specifications? How do I include energy management graphics into BMS dashboards, and other questions? And hopefully Iqenergy is the answer to nearly all of these. At the heart of the system are these modules called aggregators. Aggregators can do a number of different things. They can add together meters. So if we have sub meters, we can include them all in one aggregator. And as you can see, they operate in several different modes. These ones in front of us are totalizing. So they're adding up, for example, 15-minute values from the meters. So we can then get out our daily, hourly, monthly, yearly outputs. And these numbers can be put straight into a screen as values, as bound labels. But the most important thing the aggregators do is feed other pieces of the Iqenergy system, which we'll come onto in a piece. There are also normalizers built in. So we can normalize against other outside influences, most commonly area, so square footage of a building, so that we can actually work out how much energy is used per square meter, square foot, so on and so forth. So we can normalize buildings against one another, but also things like footfall, production area, outside air temperature, that sort of thing can all be used as a normalization component. The aggregators feed into things like these graphing widgets. So these are all fairly standard graphs that you'll be probably familiar with, including things like stacked bar and the ranking charts, which don't necessarily appear in the standard Niagara package. So things like the stacked bar chart are different, and including these pie charts and so on. I won't go into details about all of them. Hopefully they sort of speak for themselves to some degree, with the exception of the heat map. The heat map is a favorite of energy managers, and it's a good way to display the density of values or the density of data. In the instance we see here, high values are represented by darker colors, and low values are represented by lighter colors. So it is a small example, but you can kind of see that July in the middle of that left-hand part of the heat map is quite a dense block of dark colors. So in our particular example here, we used more cooling energy in that particular month than any other month. Now, this was obviously not in Britain because we don't get warm enough to really bother with the cooling all that often. However, it is a useful tool because it can be used for anything. Actually, it doesn't necessarily have to be energy data. Another part of the system are these dials. Now, again, these are supplementary to the standard Niagara ones and include things like the transparency mode for the background there, which the standard Niagara components do not do. Most of these include some sort of configuration so that you can set the thresholds. So you can see in the middle one there, we've got a kilowatt hour per foot squared, and it's got a green, amber, and red zone. And the needle will sweep through, and the colors will light up as you go. And it's a reasonably good way to bring an operator's attention to their energy use, i.e. green being good, amber being watch out, and red being better to start turning things off. And these are all freely available, and again can be used throughout the station wherever you see fit. The most important part really for any M&T package or proper M&T package are these tools. And these include things like heating degree day and cooling degree day calculators, regression analysis, and energy temperature analysis, which I'll talk about in a little bit more detail in a moment. For this particular screen though, and for those of you that aren't necessarily familiar, heating degree days and cooling degree days are a bit mysterious for a lot of people, but fundamentally they're a way of normalizing maybe month on month or perhaps year on year energy usage. So, for example, 2019 was a particularly cold year, at least it was here in the UK, and 2020 was quite a hot year. And obviously, years vary, as do months. July 2020 was much hotter than July 2019. So, if we looked at the energy use for those two months, July 2019 and July 2020 for a particular building, the cooling required in July 2020 should be much, much higher than the cooling required in 2019, it being a cooler year. And the degree days, particularly in that instance, cooling degree days are a way to work that out. So what it fundamentally means is, let's talk about heating degree days, something that's far more relevant to us in the UK because we're cold. It's fundamentally a measure of how many days multiplied by how many degrees of effort were required in heating. Now, there's a sort of threshold used here, and typically something around 15.5 degrees C. So if the outside air temperature drops below 15.5 degrees C, we turn the heating on. Now, if it drops by 1 degree or 2 degrees, that's part of the multiplier. So, for example, in January, we could have a month in 2019 in January with 300 degree heating degree days, which meant on average it was 10 degrees below the heating parameter for 30 days. Now, if you measure that against 2020 January, and let's say it was 50 heating degree days, it's much, much less energy required in theory. And it does mean we can then normalize against the outside air temperature. It doesn't necessarily mean, doesn't necessarily become too relevant. It also means we can measure buildings from one area against another area, because the number of heating degree days will be very different in January in London than it will be in Madrid in London, for example. The regression analysis is sort of fed from that. And again, it's a very useful tool for energy managers to try and work out how things are going, try and project energy management. If you're having a particularly hot year, you could work out along that slope what your expected energy consumption would be, even if the prevailing conditions are significantly hotter than any other year. You could try and project along that line. And it's basically heating degree days mapped against kilowatt hours, or how much energy you would use. And you have a heating degree day regression analysis curve and a cooling degree day regression analysis curve. There will be different. Now, what the idea behind this is to try and shift that curve down. So your energy improvement projects should lower the curve. So you use less kilowatt hours per heating degree day. And that will that's a measure of how successful your projects will have been. At the top right there's an R squared number, which is reading 0.55, as I can see on the screen here. And that's a measurement of how good the data is. So we do calculate that out. An R squared number of anything approaching 1 is very good, approaching 0 is very bad. The way it's measured is how close a fit our regression analysis line is to our data spread. So you can see in my example here, there's a nice cluster of points or samples which run alongside the line or on the line. They are a very good fit, and our line is drawn through the middle of those. The ones that are scattered either side are what is actually dragging the R squared number down, because they don't fit. And I'm guessing this is a very bad data sample. And again, it's a means that we can judge the success of our regression analysis line. Is it good? Is it bad? And so on and so forth. The energy temperature analysis is actually slightly simpler, perhaps, and it's a line drawn against outside air temperature and the heating or cooling effort. So again, the idea is to try and go from the red line, where we use more energy against the prevailing conditions, down to the blue line, where we use less. This is quite commonly used in the Nordics, not necessarily so common elsewhere, but it's actually quite a nice, simple measurement of how well your building is doing. And again, measuring year on year, if you undertake some improvements in your heating and cooling and bring in efficiencies, it's a nice way of tracking how effective they have been year on year, perhaps. The menu builder is an operator tool, really. So it's a nice way for building operators or the guys who are looking after this day by day to build their own menus, and it can all be done in the browser, so they don't have to get into the engineering part of IQ Vision and or Ton or so on. So we can build these lovely menus quite simply. You can see there's a preview on the left, a sort of toolbox on the right of things you can build in, and in the middle is the actual guts of it, where it's all where it all hangs together. In the same mode, we have energy reporting. And again, this is designed as a tool for the operators. This is all built in the web. My sample there shows buildings A and B year-on-year comparisons, 2021 and 2020. And as we're not too far through 2021 as I speak, you can see that the numbers dip off. Probably not a brilliant example, but that can be month on month, week on week, whatever we particularly feel like. And at the bottom there, I have a pie chart which simply adds up the contribution to the total the buildings A through D have actually made in June 2021. And again, we could have anything in there, and it doesn't necessarily have to even be energy data. It could be anything you desire, really. The kiosk mode is commonly used for large displays, let's say on a smart TV in large common areas. And what it will do, it will cycle through the various displays on the left-hand side there. So it just goes through the menu item by item and will revolve through, leaving each thing on the screen for 5 or 6 seconds. So quite a nice way of building in a common area energy usage display where they are required, and they often are required by legislation and or building operators. What you see there is an example of the dark theme. There is exactly the same thing mirrored in a light theme as well, as the examples we've been running through are mostly in. But the dark theme, sometimes in either iPads and iPhones, it's a more efficient way of displaying it. For common area displays, depends on the decor of the building, I suppose, but it'd be quite a nice way to fit in should you need to. We also have a data export and tenant billing package built in. Now, these are built on Excel templates. You can see I've created one there, and I will be emailing this to myself with junk data in it every month until I get really annoyed with it and turn it off. These are all supplied in there. You can see there's a PDF generator, file recipients, and an email recipient on the left-hand side. So this will churn through every month, throw values out from the aggregators into our report, format it all, and away we go. And I'll get those in the email. And that's all fully configurable, so you can make that look however you wish. It's supplied as a template, and you can basically do with it how you see the best you see fit. And finally, the stock keeping units, or SKUs, or part numbers. We have several here. For IQX and Ton, it's limited to 12 meters, so it's just the one license for those 2 devices. But given the size of those devices, that might actually represent a very, very nice solution for smaller buildings. A little standalone supervisor / energy management package all built into one unit. For IQ Vision hosted solutions, we have a base license of 25 meters, which you need to start with. And again, this is irrespective of the aggregators. As I said, this is the histories that feed into the aggregators. That's where that number 25 comes from. And to expand that out, you can see there are 4 expansion part numbers. All of this is available to order online and license in the portal. And finally, the hardest bit for me, this being a virtualized session, Q&A. Now, I'm good, but I'm not good enough to predict what questions you may have wanted to ask me were this live. So I will refer all questions to our Trend team in the field. Please feel free to ask any questions of your Trend account manager and or Trend representative, or indeed me, if you can find me. I'm happy to talk to anyone about this. But until we talk again, thank you very much. It's been a pleasure to talk to you, and I hope this has been useful for you. Bye-bye.